Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 3 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1007. Minimum domino rotations for equal row. Okay, so this problem is actually very easy. Let's read the problem statement first. In a row of dominoes, tops of I and bottoms of I represent the top and bottom halves of the ith domino. Okay, so here see this array tops. So for first dice, this top value is 2 and bottom value is 5. Okay, so see here in top you are seeing 2 and in bottom you are seeing 5, right? Same way here 1 and here 2. So here you are seeing from top 1 and from bottom you are seeing 2. Okay, so these two halves are given to us, right? Top and bottom, right? A domino is a tile with two numbers from 1 to 6 only, one on each half of the tile, right? We may rotate the ith domino so that tops and I and bottoms of I swap the value, right? So here 1 and here 2. Okay, so if I just rotate this dominoes, okay, so 2 will come top and 1 will go bottom. Okay, so if I rotate it, that's what going to happen, right? We have to return the minimum number of rotations so that all the values in tops are the same or all the values in the bottom are same, right? If it cannot be done, then we have to return -1. All right, so very easy problem, right? So before proceeding with the examples, see the constants. So constant length is tops dot length is from 2 to 2 into 10 to the power 4, and this is given that bottoms dot length is equal to tops dot length, and tops of I bottoms of I value is array from 1 to 6. Okay, so we have how many candidates? We have 6 candidates: candidate 1, candidate 2, candidate 3, candidate 4, candidate 5, candidate 6. Okay, so these are the only numbers. So here see, first see this example number 2. Okay, so we have numbers like 3 in top, 5, 1, 2, 3. Okay, and here we have 3, 6, 3, 3, 4. Okay, and we now know that we have only these 6 candidates. Okay, so with candidate 1 a result is possible, tell me. So here we have 3 and here we have 3. Okay, so with candidate 1 result is not possible, right? We can't make all the tops equal to 1 or all the bottoms equal to 1, because here in the top we have 3 and here in the bottom also we have 3. Okay, so 1 is not possible, right? Even if I rotate here these two, okay, 1 is not possible, right? So with 1 result is not possible, right? Now I will, after that I will check with candidate 2. Okay, so with the 2 result is possible? No, with 2 also result is not possible. Here you see 3 and here it's 3, right? And now check with 3. With 3 result is possible. Yes, here 3. Okay, here it is possible, but here 5 and here 6 now. Even if I rotate these two, I will still not get 3, right? So with 3 also result is not possible, right? Now check 4. With 4 also result is not possible. Okay, check with the 5. 5 with 5 also result is not possible. With 6, 6 also result is not possible. So in this case we are returning -1. Okay, in this case it is not possible to rotate the nominees to make one row of value equal. Okay, so with we check all these candidates, right, one by one. Result is not possible anywhere, right? So in that case you have to return -1. All right, okay, so this is clear. Now let's see this example number 1. Okay, so in tops we have these values, right? And in bottoms we have this value, right? So here 2, 1, 2, 4, 2, 2. Okay, and here bottoms 5, 2, 6, 2, 3 and 2. All right, so here first let's say candidate 1. Okay, with candidate 1 result is possible or not? So here we have 2 and here we have 5. No, with candidate 1 result is not possible. Now let's check with candidate 2. So with candidate 2, so here in the top, if I want to make all 2's, so here 2 is there, so no worry, right? Here it is 1, but here it is 2, so we can definitely rotate this domino, right? So if we rotate this domino, so 2 will come to the top, right? Okay, 2 will come to the top, right? So here we have to do one rotation, and here 2, no worries. And here we if 4 is there, right? If we rotate this 2, definitely, right, we 2 is going to come to the top. Okay, so here with the result is possible with 2, okay, in the top, right? And here it is 2, it is 2. So how many rotations I am doing in the top? I am doing total 2 rotation in the top, right? Now check in the bottom if with the 2 result is possible. Okay, so here 5, so we have to do one rotation. Okay, 2 is going to come here, 2 is already here, and here from top we can bring 2. Okay, so we have to do one more rotation, 2 is already here, and here 3, and from here top 2, so we can do one rotation, right? We have to do one rotation here, right? And here 2, it's already there. Okay, so that's it. Okay, so in the top I'm able to make all 2s with just 2 rotations, and in bottom also I'm able to make all 2s with 3 rotations. So out of these 2, minimum we have to return, right? So 2 is the minimum, so just return 2. Okay, so first figure represents the dominoes as given by tops and bottoms before we do any rotations. Okay, this is the original configuration of dominoes, right? If we rotate the second and fourth domino, okay, so see, second and fourth domino, we can make every value in the top row equal to 2 as indicated as a second figure. Okay, so here see, dominoes after rotation, so here all 2s are coming up, right? So see, that's it. Okay, so we are returning 2. Okay, so now after that, with the 2 result is possible, we don't need to check candidate 3 and 4 and 5. Okay, there is no need to check other candidates. We can simply return our output here too. Okay, so that's it, right? So here let's say this example, your here you have 6, here you have 6, and here you have 6, and here you have 1, and here you have 1. Okay, so now here you have a 1, and here you have 1. Okay, and here you have 6, here you have 6, and here you have 6. Okay, so now here let's tell me, with candidate 1 result is possible. Okay, so here see one more thing. So with candidate 1 result is possible? No, candidate 1 result is not possible because here we have 6 6 now, so result is not possible. But with candidate 6 result is possible here in this case, right? So here we have to do one rotation here, right? So in the top we are going to get all 6 with just 2 rotations, and in the bottom also result is possible if I just rotate this and rotate this for candidate 6. So here 2 rotations, so minimum we need to return, so 2. All right, but here let's suppose instead of this 6, here we have 1 here. Okay, so now tell me, result is possible with candidate 1. Okay, so yes, candidate 1 result is possible, right? So with candidate 6 also result is possible, but here see, with 1 what I'm doing one rotation here in order to make all the candidates to the 1 in the top. So I'm doing 3 rotations here, and in the bottom I'm doing two rotations, okay, to make all ones. So here minimum we need to turn, minimum is going to 2, right? 3 2, minimum is 2. Okay, now you are going to say that with 6 also result is possible, maybe we need to do minimum number of rotations. No, that's not right, right? So here see, with 6 also, here you are doing the 3 rotations for making 1, so left out is 2 part. Okay, so you, in order to make all 6, you have to do 1 rotation here, 1 rotation here. So now in this case, in top you are going to do 2 rotations, and in bottom you are going to do 3 rotations, right? So again 2 and 3 minimum we need to then give na, so 2 is going to minimum only, right? So it's very clear, right? So whatever the first output that you are going to get, that is the answer. Okay, whenever the valid answer is there, first valid answer, that is going to be your output. Okay, right? So because here the first number with which you are first candidate with which you are going to get the particular answer, definitely that number will be there, maybe in a top or maybe in bottom. Okay, that number will be fixed always. Okay, maybe in the top or maybe in the bottom. Okay, so here in this example, if you see, uh, 2 is the first candidate with which you are getting the result. Okay, so you see that 2 is going to be always there, maybe in the top and maybe in the bottom. Okay, so if 2 is here, then here you see 2 is here, here you see 2 is here. 2 is always there, right? With the 2, the first valid answer is possible, right? So now what are the other choices left you have? Okay, so here 5 and here 1, definitely they are not going to the part of answer, right? This 6 is not going to part of the answer, this 4 is not going to be part of answer, this 3 is also not going to be part of answer, right? Because all the values here you see in other corners are different only, right? But here in this case, uh, here in this case, two values are possible, right? Because we have only 6 and 1s. Okay, that's it, we don't have any other number other than 6 and 1. Okay, so we check this scenario as well. So in the top, if we are just converting all the candidate keys to 1, so in top we have to do 3 and in bottom we have to do 2. But if we want to check for 6, okay, so in that case we have to just do the remaining portion. Okay, 2 2 here and here also 3. So with, so here with this also 1 also we are going to get minimum 2, and with candidate 6 also we are going to get minimum 2. Okay, first valid candidate with which you are going to get the result, that is going to be your output. Okay, that's it. Okay, so now let's write the code, and code is going to be very simple for this problem. So here for loop first. Okay, and we know that we have candidates from 1 to 6, right? So here run one loop, for loop candidate is equal to 1, and here candidate it should be less than equal to 6, and here just increment the candidate plus plus. Okay, so with all the candidates we are going to check, and whatever the first candidate with which answer is possible, we are just going to return that particular answer. That's it. Okay, so here int min rotations in the top. Okay, min rotations top, and set it to 0 initially, right? And now same way just copy it. All right, and here use int min rotations in the bottom, and we are going to check whether this candidate is valid or not. So boolean valid is equal to true, right? Done. Now here after this we have to check if we can make all the candidates all the values in the top equal to that particular candidate, or all the values in the bottom equal to that candidate, is if it is possible or not, right? Int I is equal to 0, I is less than tops dot length. Okay, so it is given that tops dot length is equal to bottoms dot length, right? I will check if my tops of I value, okay, if it is not equal to candidate, and my bottom of I value is also not equal to candidate. Okay, so then that simply means that with that particular candidate result is not possible. Okay, is not equal to candidate. Okay, candidate. So in that case we are just going to set valid is equal to false, and we can simply break this. Okay, that's it. Done. Break this. Okay, so now here after that, here you check now if this condition is not valid. Okay, if this condition is not valid, right? So in that case what we are going to do, we are going to check if tops of I value, okay, if it is not equal to candidate, right? So in that case what we need to do, we have to check definitely in the bottom we will have that candidate, right? So here and bottoms of I value is equal to candidate. Okay, so if this is the case, right? If this is the this is the case. Okay, so we have already checked one case here. Okay, so in that case you have to just do one thing here. You have to write min rotations top plus plus. Okay, so min rotations top plus plus. All right, and here also you can just copy this and paste it here. Now same way we have to check for the bottoms, right? So here just copy this, and here write bottoms of I, right, and tops of I equal to candidate. Then min rotations bottom you have to update. Okay, bottom you have to update, and here after this, okay, here your for loop is running. Okay, so here you have to check if valid. Okay, if valid, so here in that case you have to return what you have to return here, math dot min of min rotation stop. Okay, just copy this, and here you have to write min rotations bottom. Okay, that's it. Okay, done. And here you have to simply return -1. That's it. Okay, now let's run the code and see if there are any code issues. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And here can I do few more changes, right? Here I'm checking if tops of I is not equal to candidate and bottoms of I is not equal to candidate. Then I'm setting valid is equal to false, and I'm breaking this. Okay, I'm breaking this, right? And here I'm checking if tops of I is not equal to candidate, then definitely my bottoms of I is equal to candidate. Okay, so I don't think I need to write this. Okay, so I can remove this. All right, so here also I can remove this because here we have already checked now this case, right? So now let's run it. So see, all the test case has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So the time complexity for this problem is going to be of n. Okay, so this is running only 6 times, right? And inside this is running tops dot length, let's say n time. Okay, so 6 into n, you can say n only, right? So the time complexity for this problem is going to be of n. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.